Everyone, I'm Wonli. I explained or introduced expectation last time. It means mean, okay, average. Today, I'm going to start introduce some important probability distribution function. First one is Bernoulli distribution and binomial distribution. Let's see, okay, here, Bernoulli probability distribution. Let me introduce the simplest discrete random variable. This is the case where there are only two kinds of data in the population. We call the outcome of an experiment either success or failure. Okay, success means good, failure means bad. No, that not that. Just distinguish two of them. One is success, the other is failure. Okay. In this case, we define the random variable x as x takes only two values, 1 or 0. So simplest discrete random variable. 1, x equal to 1 if success, one outcome. X equal to 0 if failure, the other outcome of experiment. Okay. And probability of x equal to 1 is p. What is that then? Small p. Small p is success ratio. Then the random variable x is said to follow Bernoulli distribution. Here, probability x equal to 1 is equal to probability success. This probability is this probability. So let that probability be small p. P is success ratio. The population, the random variable as follows Bernoulli distribution, consists of simple data that can take only two values, 1 or 0. For example, population data takes pairs such as defective or non-defective, support or non-support, pass or fair, urban area, rural area, male, female, and so on. There are many kinds of this kind of only two outcomes of experiment. Let's consider population of 44 million voters regarding their support for the president. In other words, the population consists of 44 million instances of support that we say success, or non-support, we say failure. In this case, they define the random variable x like this. If support, x equal to 1. If not support, x equal to 0. X is defined as above, then the population consists of 44 million values, 1 or 0. Population, 1 or 0. Okay, there are many, how many? 44 million, many, 1 or 0 value. Each sample point taking a value of either 1 or 0. We take 1,500 sample size, then the sample values would be 500 instances of 1, 0, 1, 1, 0, 0, 0, dot, 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 1. How many? 1,500 many, 1 or 0 values. That will be a sample. If the number of ones is 600 out of 1,500, then 600 over 1,500 equal to 0.4. That kind of thing, what does that mean? It represents the sample ratio, sample support ratio obtained from the sample of 1,500 people, right? So this Bernoulli distribution is related to proportion or ratio. We will consider it later. Thus, Bernoulli distribution is the simplest form of distribution, and the probability distribution function for Bernoulli distribution is f of x is like this. Can you see the form of this formula? Probability distribution function, x equal to 0 or 1. Okay, f of 0 is 1. 0, p0 power 1 minus p, 1 minus 0. That's going to be 1 minus p. What is 1 minus p? This one is probability x equal to 0. F of 1 is P, just P. This is what? Probability x equal to 1, success ratio, right? So this one in a line is representing the probability distribution function that for x equal to 0 or 1, that the probability function f of x greater than equal to 0, and the sum of all x's equal to 1. 1 minus p plus p equal to 1. So I think you don't have to memorize this one, but let's see the graph of a Bernoulli distribution. When x equal to 0, 0 here, f of 0 is going to be 1 minus p, this height. And x equal to 1 here, this one represents the probability when x equal to 1, p. So sum of those two heights going to be 1. Okay, this is typical discrete probability distribution function, f of x, right? When x has a Bernoulli distribution, it is denoted by x tilde BER, Ber, with P. P is unknown value. P is unknown value because it is for population, it is for X. So there exists some, say, support rate for the president. Then we do not know, we never know 44 million people's support ratio, right? Now, we can calculate the expected value, mean, and the variance of a random variable x that follows Bernoulli distribution like this. F E of x, expectation, and shortly we denoted Greek letter mu. What? X takes 0 or 1, x expectation of x is 0 times its probability, f0. What is that? 1 minus p. And plus 1 times f of 1, what is that? It is p here. So the mean of this Bernoulli distribution going to be p, right? P. And the sigma square, it is variance of x. Variance is what? Deviation is like this. So squared deviation, this one, average, mean of squared deviation. That is this. So mean of this one, x, small x minus p, p is mean, right? Square times f of x, its probability. So sum x equal to 0 to 1, only two sums. So 0 minus p square times its probability, 1 minus p, 1 minus p square times its probability means probability of f of 1 is p. So we, simply we get result p times 1 minus p, like this. Okay? It is the first expectation and variance for this simple probability distribution function. Binomial distribution is some famous probability distribution for us because we use this binomial distribution for real problem. So binomial distribution, you may study this binomial, but you never studied Bernoulli. But I think Bernoulli distribution is more important in statistics. Okay, I think I will explain binomial distribution later. Okay, today that's it. Thank you. Bye.